Olá, Coimbra. Sou Matheus, muito feliz de estar aqui. And that's all the Portuguese I got for now. So, yeah, we're here to discuss some speed at scale. This is me. By the way, you can find me everywhere as Y Combinator. I am a senior software engineer at Medallia. I'm part of React Summit NYC committee and GD in web technologies. Before we start, I want you to know a little bit more about the session, but I want to know more about you. So can we raise your hands here? Who's here working with front-end? Okay, the vast majority. Great. And with React? Okay, kind of half of you, I guess. So the post that motivated this session, it's called Silent Engineers. And there's one quote I love about this post. It starts like, while browsing Hacker News, I sometimes get a feeling that every developer out there is working for a FANG, as there are always posts from those people doing some hype stuff. And he goes, so, but let's be straight, that's like 1% of all developers out there. The rest of them are just lurking in code with their language of choice and being happy with it, be it Fortran, COBOL, Perl, PHP, Java, whatever. So this talk is not about, unfortunately, not about the state-of-the-art things on Solid. You've had plenty of them, or Astro, or others. I myself also have a session about this, but this talk is about web performance and realities of your industry, our industry. So there's this very famous meme on web performance that web performance is just simple as drawing a horse. You just got to do these 4 basic steps, and then just figure out some tiny details, and you're good to go. It's supposed to be fun. And so that you know about the industry I'm talking about. So I work for this company called Medallia, which is a customer/employee experience company, more specifically in the survey team. So imagine anything you get when you go to a bank, when you buy something at a store, etc. And this talk is about this project and how we modernized dependencies, how we did code splitting, how we did React, how we managed to do all of this while targeting different browsers, but also about some challenges you might face in legacy code bases, our experiences, what we have in our radar, and some lessons learned along the way. So better rush. So the first part, modernizing dependencies. So when I talk legacy systems, I'm talking this kind of thing. So I don't know if you in the back can see it, but React 15, Node 10, first version of Webpack, and etc. So let's start with Webpack, right? Because we had a long way out to Webpack 5. You've probably seen a lot of cases, or maybe at your companies, you've seen how people improve performance by using Webpack 5 and all of the fancy things it has with caching, proper tree shaking, and all of that. But the other side of it is migrating, especially if you're in the first version, can be tough. So you'll find a lot of conflicts amongst your dependencies and your loaders and all of that. Not to mention that a lot of APIs, they're changing from one major to another. So the gotchas we have here is that, first one, migration is about having all of your plugins and loaders not only being compatible with Webpack, the Webpack version you got, but also with each other. And that's super tricky if you got a few of them. The second thing is you cannot go to V5 from V2 or V3. So each process is an entire different process that has to be done sequentially. So try not to stay super behind. And the third thing is, for example, Webpack V5 has Node 10 as a minimal requirement, but you'll find that a lot of the loaders or plugins that you're using, they might have different requirements. So even though you're conforming to Webpack requirements, you might have to go to Node 12, 14, or 16, depending on your dependencies. So let's upgrade Node, specifically going from Node 10 to 16. I don't know if you've ever been in a similar process, but there were a few changes in the workings of VH that impacted this a lot. And more specifically, Node Fibers. So Node Fibers is a package that is behind a lot of the popular packages we have out there, and it just stopped working as of Node 14. By the way, the team from SAS, they have a really good post on this and how this process went for them. So, okay, Webpack, we're good. Node, we're good. Let's talk about React. So going from React 15, who here has done React 15, by the way, in class components and, well, half that done Webpack. So It is a common thing that when going from a major to another, you will notice some decreases in the overall bundle size. More specifically, going from 15 to 16 means a 32% cut in overall bundle size. So by updating React itself, we're sparing some extra kilobytes. But the first gotcha here is this. So we were using prop types, and prop types are part of the React package in React 15, but they're a different package in React 16. So how can you smoothly handle this? Then I thought, it was not the first time I was upgrading from React 15 to 16. Back at the time when React 16 was launched, I had to update a code base, and I even had a talk about that. And the core of the talk was JS code shift. Who here has heard of this thing, JS code shift? Okay, 3 of you, great. So the short thing is JS code shift is a tool that runs in transformation script over one or more JS or TS files. And there's a lot of explanation around ASTs and etc. But the lucky thing is JS code shift has, there are a few open source packages that work on top of it, and React Code Mod is one of them. So React Code Mod is a set of JS code shift transformers that are aimed at helping you upgrading your code base. And one of these code mods is the prop type thing. So you could automatically update all your prop types by running JS code shift. But the gotcha was, okay, how to hide all of this behind a feature flag? Because we had a lot of customers and we couldn't risk this migration to break things and etc. So it should be an opt-in mechanism. So here comes the code generation part. So just for you to have an overview, this is what we wanted to do. So in parallel, we wanted to have different versions of our developer dependencies, so Node.js, Webpack, Babel, etc. Also different versions of what was running for the client, so React itself. And also different strategies used for bundling and serving those different versions of things, so different config files, etc. It's easier if you can visualize. So before, what we had was something like this. So we had packages, and then the first package would be the core of the application itself. A second package would be where we kept our end-to-end tests, and so on. So we wanted to go from this to this. So breaking down things, so legacy A is where is the default bundle that is served if you wouldn't have this feature flag enabled. And that's where the active development of the application kept going on. So new features, bug fixing, all of that. And that's also the code that we kept tracking in the Git repo. So, and then you have the legacy dependencies. So React 15, Webpack v1, Node 10, and etc. And then we would have this next wrapper here, not to be confused with Next, the meta framework. So under Next, is everything that is hidden behind a feature flag. And we had the modern dependencies, so React 16, Webpack 5, Node 18, and all of that. I know there are other versions of React, and the 16 is not the most modern one, but it was here. And most of the things that went inside this were code transformers, automation scripts, and the new Webpack and Babel config. And also, some parts of the code that we didn't manage to code generate. So some of the test files that we're using, like legacy APIs of Jest, of Enzyme, or other testing frameworks, we had to manually update these. And then, within this thing, we would have the code that is generated. So we would have tons of code being generated in the CI, or you could also run them locally, and those would be our React components, the utility functions, most of the business logic, etc. And this code is never pushed. So we would also code generate a git ignore file that would have more than 1,000 lines to avoid that duplicate code was pushed to the server. So a very, yeah, maybe contrast isn't great. But basically running, you would see something like this. So you're copying files, you're moving files, you're applying transformations and all of that. Speaking of transformations, so I would really recommend you to check this tool. It's called AST Explorer, and it gives you a very, very good visibility on what your code gets translated into once it's run. And you can, for example, understand like a simple import React statement, what it's becoming. So on top of these AST explorations we did, we wrote JS code shift transformers. The anatomy of a transformer is like this. So a JS code shift transformer gets a file, and then it has a lot of functions. Here, for example, I'm finding the declarations that are called full and renaming them to var, and then returning a new source code. So this is like hello world for it, so we would write more complex custom transformations. And the way we abstracted things were in transformers groups. So each transformer group would have a nice label to basically say what that transformer was doing. It would have a file pattern to match, so it could know which files to apply that transformation to, and also the path that would point to a JS code shift transformer that we wrote or that we were using from open source, like React Code Mod. And then all we had to do was iterate through these groups and apply the transformations to them. So that was kind of React. Another thing we also had to update was WebDriver. So WebDriver is an end-to-end testing tool that we were using. It was in version 4. We went to version 7. And we had a similar problem as Webpack. So you can go from 4 to 7. So we had to go 4 to 5, 5 to 6, 6 to 7. Luckily, again, there were code mods available, so provided by WebDriver itself. So for some of the things, it was just a matter of running this code transformer. And as they say, no more changes necessary. But again, some gotchas. So due to the way that V8 works under the hood and no changes and all of that, there were some of the APIs that just couldn't be migrated automatically. So they discriminated all these special cases, and we had to manually fix them. So that was it for modernizing dependency. Another thing we did was code splitting with dynamic imports. So you're probably familiar with this. So basically, we had a few very, very large chunks of code that were not necessary for some surveys we had. So we split them in different things. If you're familiar with React, you can do this with React Lazy and Suspense that are available as of React 16. And we got some cool results. So the baseline got way smaller, and then depending on the types of questions you would have in a survey, they would be downloaded afterwards. So you would download only the necessary kinds of questions that are being used at your current survey. But just like any other performance optimization, these are not always for free. So we had a few gotchas. I guess the highlight was because we allow customers to write some custom code to run in their surveys, like JavaScript, CSS, we had to watch out for the code that was being dynamically loaded because they were trying to customize code that wasn't loaded yet. So we had to revisit this. Third thing, Preact. Has anyone ever heard of Preact or used? Okay, quite a few hands. So for those who are not familiar, Preact is this lighter alternative of React that has like about 10%, has a way smaller bundle size. So we also managed to adopt Preact by allying our production builds to Preact and its compatibility layer. So by doing so, we also got a few extra kilobytes, going from 205 to 175, again, with gotchas. So some of the Preact issues, they were exacerbated when combining Preact with Suspense and React Lazy. So the performance trade-off we did was to replace React and Suspense and Lazy for the old way of doing dynamic imports in React that is loadable components. Wow. So part 4 is how we shipped all of this while maintaining compatibility. So I don't know about you, but it's not often that we check which browsers are visiting our apps. But you would be surprised, depending on the scale in your markets, that people out there still use Nokia browsers or Blackberries or Internet Explorer. So you should ship polyfills, but at the same time, you should watch out for Lighthouse because you might be sending unnecessary polyfills to modern browsers. So revisiting these strategies we got for polyfilling, the first one is polyfill.io. So polyfill.io is a very, very popular service that basically it's going to inspect the user agents of your browser and send us the polyfills that are targeted at that browser. And it also has a very, very nice UI that you can pick some specific polyfills. As a third-party script, you might be adding some extra milliseconds setting up the connection to their server and etc. And one thing to know is, depending on your SLAs, because it's a third-party thing, you're also subject, in the unlikely event that they would have some outage, that probably means an outage of your product too. Okay, so second option was the Babel plugin preset. So preset, you have an option called use built-ins, and you have two available values for use built-ins. The first one is use built-in entry, but the trick here is that it's not really super useful if you're targeting very old browsers like Explorer. And the thing is, it might remove some polyfills, but most of them are going to be bundled and still downloaded by everyone. And then you have the other options, that is use built-in usage. So the trick here is that it's not adding polyfills for your dependencies unless you're piping your dependencies, like your node modules, through Bubble. So that might be a problem. And the second thing is, it's not very smart in the sense that, for example, if you got array.includes, it's also going to add a polyfill for string.includes. And if you got symbol.toString tag, you're going to get polyfills for anything that's called toString tag too. So third option is what's called differential serving. So there are a few different ways that you can do differential serving. One of them is by leveraging the no module / module thing that browsers have. So the way you split is, if you don't have ES6 support in a browser, like Internet Explorer, it won't load anything that's called type module, the scripts that are tagged as type module, and it will load the no module ones. And you can use no module to serve the polyfills for the browsers that need them. So it basically looks like this. You add script, no module, and then you serve the bigger version, and then you got script type module, and then you serve what's targeted at modern browsers. So summing up, you got polyfill.io that is easy and doesn't ship anything to modern browsers, but it might increase some core web vitals like TTI and FCP, because again, it's a third-party thing. You got use built-ins from Bubble preset that is easy to set up, but it's either not very useful for old browsers, or it's going to require you to pipe your node modules through Bubble. And then you got the no module versus module thing that is easy, and it has wide support, but it's only going to cover ES6 versus non-ES6 polyfilling, which was good for us. And then you have different ways to apply this thing. So you have just using raw module, no module distinction, but then you're going to see that there are some inconsistencies across browsers. So for example, you might end up in scenarios where both scripts are going to be downloaded and executed, or both of them are going to be downloaded, but just one executed. So there are a few inconsistencies you would have to handle. The second way is you can leverage user agent detection. So basically, this can be your expert Node.js server, Java server, whatever. But the trick is, and that was our scenario, you might not be in control of the server. And that was our case. So the server that was serving this React application was owned by an entire different team, and they didn't want the complexity of adding user agent detection to do our purpose. Also, depending on how you load it, you're missing some of the benefits that you have from script type module. And the last thing you have is runtime detection. So you can basically add another script tag that is going to detect whether this browser is compatible with module versus no module thing, and insert the right version. So summing up, this is what we had. So out of the available polyfilling options, we went with module versus no module. And out of the different ways of serving these different modules, we went with the runtime detection. So that's the summary. Some results we got. So first, we got a lot of huge pull requests that took a lot of time to review, because they were basically touching hundreds and hundreds of files and hundreds of thousands of lines. But unit tests and also our end-to-end tests were passing at the end. In terms of bundle numbers and button footprint, so we ended up with two. If you were to adopt this new feature flag, you would have two bundles. The modern bundle had a 37% cut, going from 279 to 176. And the legacy bundle that is served to the legacy browsers would be 25% smaller. So in numbers, this means the ones that do support module and the ones that do not. As of yesterday, that meant almost 97% of browsers worldwide. And for us, this was our cut, so only 0.2% of customers the ones using Internet Explorer would get the bigger bundle. Speaking of core web vitals, most of them improved. So we got a 6 seconds faster FCP, 3.5% faster speed index, 2.4 seconds faster LCP, and 2 seconds faster TTI. Other metrics also did improve. So timings, those are coming from web-based tests. So you can see when the feature flag is on versus when it's off. And all of these improved. Overall visual progress, that is basically how faster your users are going to get the content of your app and etc. also improved. Oof. So there's still a couple of things we have under our radar. First, overall, culture and tooling can always be improved. So, for example, checking things like bundle phobia before you add another library to your project, or using some VS Code extension that is going to flag the bundle size and etc. Or using dev tools to figure out some unused bytes of the code that you're loading. Not to mention new tools like Million.js. They are working on maybe beta version of their plugin for VS Code that is going to spot possible enhancements for your React app. Also, offloading third-party scripts with something like Parentown by Builder.io is also something we have in our radar. Using different compressions algorithms other than just plain zip. So nowadays we got Broadly, Zofly, Z-Standard, Gwedsley, and many options for better compression of text, of images, etc. Not to mention things like Quick, part of the HTTP free spec that can cut off a lot of time on round trips. So literally on the front and on the back, there are a lot of things that can still be improved, not to mention an ever-living culture process. So a few closing thoughts before you're free to go for a coffee. I always insist that sometimes understanding the internal of certain tools or of your language or whatever you're using might help you create your own abstractions. And I think that this case that I could briefly surface is one example. So leveraging AST Explorer, understanding the AST of our React code and writing transformers that would refactor our code for us and allow us to ship both legacy and modern code that is toggleable via feature flag is one really good example of it. Not to mention, have you ever heard of Elm or PureScript? Yeah, very few hands. So these were efforts in the past in the front-end realm that really pushed to optimize performance or how safe your code is and this kind of thing. And they had a huge, huge compiler basis behind them. We also have recent efforts. So what Svelte does with its compiler, or the thing we knew as React Forget, and it's now officially the React Optimization Compiler, and etc. So I think that these are really poster boys of how internals can help you with your day-to-day job. Second thing is, and about polyfills, is you probably have to ship polyfills for all the browsers your users might use, but at the same time, it might be a bad idea to ship all of them in a preemptive way, just thinking of what's theoretically possible. So do think of the trade-offs around there. The other thing is, do not take fast networks, fast CPUs, memory run, and all of this for granted, because it might not be there. So it's really key that you test on real devices and real networks and that you have them in mind. And there are a lot of very, very interesting reports on quality of connection and quality of devices around the globe. This performance inequality gap is a really good one regarding last year. The cliche is true, so as always, there's no silver bullet. These were things that worked in our very specific case. Some of the things that work for us might not work for you, and vice versa. So it's really important that you identify what are the key metrics for your product, your business. And speaking of business, it is really key that as much as you can, you try to correlate performance metrics and whatever you see on Lighthouse and other auditing tools to your business metrics, because at the end of the day, these are the ones that matter the most. The slides for this session and other sessions I got on internals of tools, on web performance, and a lot of other things that are available there. I'm going to be around for the rest of the day, and muito obrigado.